I think we're at the time, and we're asked to get started on time, so we'll give it a go. So just to get started, give a bit of an overview about what we're hoping to cover. It's late in the day. We know it's been a productive conference, and so folks may be a little bit ready for something lightweight. So we're going to do a little tech strategy, discuss architecture, and maybe a little AI. So hopefully it'll be brief. By way of intros, my name is Dan Schwartz. I've been involved with CDM for about a year and a half, 2 years, primarily from the technology perspective. I'm a maintainer in the Technology Architecture Working Group, former managing director at NatWest Markets, former CIO at Cloud Margin, and run a consultancy called FT Advisory, which is a tech consultancy, and our focus on capital markets. And with me today is Plamen Neykov.
Thank you. A few words about myself. Like Dan, I spent maybe 20 odd years in the investment banking industry, predominantly on the technology side. I run globally the front office function for a German bank. Spent some time with other tier ones in my time, and now I'm running a small valuation and risk company called CLOUDRISK. Got engaged with the Python generation of CDM, which was quite enjoyable and interesting experience, which prompted then this cooperation to outline a couple of, potential details of a reference architecture, but I'm sure then we'll continue from here. Thank you.
Okay. Thanks, Plamen. So, look, we have three things we're going to cover today. The first is the potential for CDM to radically reduce the cost for OTC products. For those of you who were in the LLM CDM section, we're pretty much covering what ChatGPT said in a 5-minute query. The second is to talk about what a reference architecture might look like to realize those gains. And then we'll talk about some findings that we have around use of ChatGPT and CDM. And then lastly, if we have time, we'll do a little demo of how the architecture might work and cover questions that you might have. We build ourselves as reference architecture and LLM. To be honest, I think we're more promise than delivery on LLM. So if that's what you're here for, sorry. Okay, so let's quickly level set. We're assuming folks are familiar with CDM, but just to quickly level set, CDM, an industry standard for common data and event modeling for OTC products. What's important, though, for this conversation is that CDM comes with core libraries. So if you're building in Java or you're building in Python, or for that matter, Go or some other languages, you get a distribution that describes the model, and you get a distribution that describes the events. So this fact, again, at the risk of repeating the LLM session, it opens the door to some radical reductions in operating and development costs for OTC products. Why do we think this? Every OTC trade has unique terms and conditions, and despite standards for the terms and conditions, many lifecycle events, for that matter, the data model itself, the implementation is left to each counterparty. And then lack of standardization has the likely outcome that the ability for parties to communicate is really challenging, and in fact, not unreasonable to call it a Tower of Babel. Participants do not and cannot fully understand each other. Even reconciliation, honestly, is a challenge because participants have to extract their data and get into some format, and then that needs to be compared. And so the different internal representations mean that the ability to agree on details is challenging, and common definition and implementation for data and event standards creates this opportunity. So what do we mean by the opportunity? It's really we think that there's the way forward is that collaboration shifts. On the one hand, there'll be an action, an execute, a confirm, reconciliation, margin flows, reset, et cetera. And on the other hand, we'll have essentially the other party receiving the information and then choosing to accept or reject. So that the whole thing reduces from all the complexity of OTC derivatives or OTC products, life cycle events, down to a collaboration which is really 5 states. Send, receive, accept, reject, and in the case that it hasn't been accepted or rejected, recalled. This standardization of function is really what we believe to be one of CDM's true innovations. There have been data standards, FPML would be the example, but those data standards miss the implementation of function and shared code. And so CDM, what we're talking about is how do you exploit this in a collaboration infrastructure. And we really think this is a different collaboration protocol. And point of fact is, it's not only a different collaboration protocol from the perspective of the states that the data has to go through, but also from the perspective of there are some activities that take place in OTC derivatives, which are really the same for all trades. What's an example? An allocation is the same, whether it's an interest rate swap or a CDS or a more complex product. So that we can have a standard data model, and that we can have actions on top of it that are standard. All of a sudden, we ought to be able to see a simpler operating state. Sorry, wrong way. So look, you might guess we think this is a big deal. It's an entirely different approach to collaboration. And we think the implication is actually big on an operating perspective. Reconciliation becomes much easier, but also on an implementation perspective. Because all of a sudden, firms do not have to model the trades themselves in code, and they do not have to model the actions themselves in code. Instead, the industry is using a standard. And so that's the driver in our minds to where the savings come from. And the savings can come whether it's internal or external. Internally, you might choose to adopt CDM for your trade processor. And we've seen similar kind of activities in tier 1 banks with FPML, where they use FPML at the core, and that what happens thereafter is a big operations on a big blob. But you can also, of course, and I think this is much of the industry's flight, you gain benefit externally with reporting, and really the full-on gains are end-to-end. Take it in, use it internally, use it externally in a common format. I can't tell you explicitly how much that savings could be, but I can tell you anecdotally. It wouldn't be surprising to me if the industry were to adopt CDM end-to-end, that the savings would be new operating expense pennies on the dollar. And this is a radical change, right? I mean, we were all struggling with cost savings that are 5 cents or 3 cents on a dollar. And all of a sudden, to reduce the operating expense to 10 cents on the dollar, it's a whole different story. So this is why we think it's a big deal. And I think it's also important to say that shifting to standard not only will create operating saves, but it'll also shorten our time to market when we have innovations. As long as the innovation sits within the framework, and the framework's very flexible, all of a sudden we pick up, like new trade type, we pick up allocation. Why? Because we've already sorted what allocation means. So it's the time, we call that the time to market for innovation should be materially shorter. And then the other question is, when we're creating efficiencies, can we gain benefit? And we'll call that time to volume. How do we support our operating platform more efficiently? So we think that that will also be a benefit. So if you accept all that, and I know it was a lot and I went through it quickly, but ChatGPT did it earlier in 5 minutes, so you know. Let's talk about what a reference architecture might look like that would enable these saves. And the first thing, the reference architecture for a level set will not be complete. It's really intended as a start. And of course, we don't have a lot of time, so we'll cover it as quickly as we can. So let's talk about what would be a good architecture, some principles. First, we want the collaboration to occur in a secure fashion. The participants who are sharing information should know that their information is being shared in a secure way, where only they have access to their information. Secondly, the enablement has to be mutual, which is to say the participants decide who they are going to collaborate with. Information in transit and at rest is understandable only by the entitled counterparties. I said that. There needs to, and then what happens afterwards, after the transport, is an engine which will enable the functionality that we want to have, we want to provide in the collaboration. So that engine might be handling atomic states. I've received your message. That engine might be handling more complex things, like I'm able to reconcile. Data, should we have data saved? We have some objectives for that as well. Data should be saved in a warm format, so we have, write once, read many times, so it's available, so we know that it hasn't changed. And bitemporally, probably a similar requirement, which is to say that we know when the data's been captured, and we also know when the data is valid. So let's translate this into some pictures. And we'll give a high-level orientation to what the conceptual components are. Here we have two participants in the in our infrastructure, a bank and a hedge fund. And the bank in this case will be a publisher, and the hedge fund will be the recipient in the main. The dark blue components are network components. There's a directory, there's a router, and there's a collaboration network, right? So the directory is responsible for, oh, sorry, let me finish explaining what the components are. The light blue component is our workflow engine. The green arrows are one-time interactions, and the white arrows are our ongoing interactions. The numbers take you through the sequence. The bank issues a message. It's delivered to the router. The router interacts with the directory to say, are the participants enabled with each other? If so, it routes the message to the hedge fund. And the hedge fund receives the message, decides what it's going to do, and that's then routed back to the bank. So one thing to make note of in the collaboration network is we're depicting this as one bus, but really it's a collection of buses. There is a publish read-only network, so the banks and the hedge funds can publish to. And then there's the router is the only thing that can consume that information. From there, the router has private queues with each of the participants, right? So this is the way that we maintain that the data that's in transit is only available to the participants that should be able to see their information. Sorry. So let's drill a little bit into the router. So just going to reiterate, this is, it's pictured as one bus, but is really a read-only bus available to the router and independent queues that are private available to the, available between the router and the participants. So the details of the flow. The bank encrypts and publishes its data. The router receives the information, looks for the counterparty, checks with the directory whether the counterparty is enabled for the bank. If it is, it routes the message to the hedge fund. The hedge fund receives the message and decrypts it. It decides what it's going to do with the data and then publishes its response. Not shown, but the similar kind of flow comes through through to the router. The router recognizes that the hedge fund has published the information and knows that the bank is ready to receive it. It's also worth noting that, again, it's a reference architecture, but we think that for our reference architecture, the best practice would be to distribute client libraries so that integration is facilitated, right? We want the bank and the hedge fund or any of the parties to have the same technology for integrating. If we drill a little bit more into the directory, so we said earlier that the green flows were one time. Here, the bank joins the network by providing its public key. So does the hedge fund. The bank says, I want to enable flows between myself and the hedge fund. And the hedge fund sends the same thing, and at this point, there's a relationship established. And then that relationship is used by the router to decide whether it can route traffic between the bank and the hedge fund. Again, client libraries distributed as a mechanism to ensure consistency and ease of integration. Okay, really the core of the architecture is the workflow engine. And here, it has two main parts. Obviously, we have three, but the two main parts of consideration are the director and the actions adapter. And the director is really responsible for taking information off that it's received and decrypting it, or taking information that it wants to publish and encrypting it. The actions adapter is the place where the logic that comes from CDM or is atomic or is custom built is encapsulated. It's essentially an abstraction to facilitate the workflow. So if the workflow is available in CDM, then the workflow is available in the actions adapter. If the workflow is custom built and enabled, then it's available in the actions adapter. And then we have, as we mentioned, a data repository. We'll talk about that in a moment. So just drilling through to the actions adapter, right? So we're showing really the three components. The first is that atomic actions, right? The enable, send, receive, accept, reject, recall. These are the basic actions that every data exchange goes through. And honestly, if you've studied the workflow step, business event logic in CDM, this is implemented in its design. The second is CDM-defined actions. You can create a trade, you can reconcile a trade, you can allocate a trade. In as much as the actions are implemented in CDM, they're available in the adapter. It's going to be a process to implement to wrap each one of those actions. We may get to the place where, collectively we can systematically bring in those actions. I think that would be the goal. And then lastly, using the same framework, participants can create their own custom actions. So, went through it very quickly. I said questions at the end, but we have some time since I went so quickly. Are there questions? Go ahead.
On the slide itself, right, you're talking about custom actions and you're leaving it up to the participants to kind of decide on the custom actions. How do you actually, is there any form of some governance model around what the participants create as a form of custom actions? I mean, there could be a lot of redundancy which could be built in. If we just leave it up to the participants.
So I think, to me, there's two questions embedded. The first is there's a permission scheme, which we haven't really talked about, right? It's not enough that necessarily the parties have agreed to enable each other. In fact, they're going to agree to enable each other for a certain set of things. So that's one piece that has to be worked through, right? That just because an action is available doesn't mean that the bank wants to use the hedge fund's action. Actually, I think there are three things. The second is, I think that the party should be open to adding actions that they want, and they might be things which are collections of actions which, let's say, I want to make create and allocate be an action, two valid CDM actions, and combine them into one. So I think that the party should be able to do that. I think there is some, but there is then some governance that could go on where you want to, what you really want to ensure is that if there's a CDM-based action, you don't want a custom action that replicates it. That to me seems like a governance that should come to pass.
But is it currently built in on this? Or?
What we're discussing now doesn't exist, right? I mean, other than some prototypes, right? So the answer is no, because it doesn't exist. Right? The goal for this is to talk about, our goal was to talk about, okay, if data modeling has been accomplished by CDM, which seems by and large it has, what happens next? And what happens next, it seems to us that the industry gets value next by incorporating action modeling, event modeling. Any other questions? Go ahead.
How does this workflow compare to doing an OTC transaction through MarketWire? And then how would you maybe compare the schema to CDM?
So, look, the thing that MarketWire has that this doesn't, well, this doesn't have much of anything because it's still a picture, right? But the thing that MarketWire has today, Astra has, or other utilities have, is the network, right? So that's the first thing to acknowledge. Getting the net, when Plamen and I chat about it, we pretty much come to the conclusion building the technology is the easy part, right? As much as I wish it weren't the easy part. The hard part is getting people to use it. I think that in the main, the MarketWire states, affirmation, confirmation, et cetera, are going to be replicated in CDM. Whether that's what MarketWire adopts is a different question, right? And lastly, again, the network, MarketWire is everywhere, right? It's it's integrated. I remember when we were doing Dodd-Frank integration, folks were saying we need to use MarketWire affirmations in our CEF flows, right? So, can the industry reap huge benefit in many different ways by standardizing its function? Sure. What's the journey? That's a good question. Any more questions? No? Okay. I'll give it over to Plamen to talk about some of our AI stuff, and if we still have time, happy to show.
Can you, your mic,
I'll give you the next slide.
just give me the next slide, please. Thank you. Yeah. So we a bit overpromised in terms of LLM outcomes and results. However, I think our results are still valid. And what we did, in contrast to the many other LLM sessions we had today, is we looked specifically at the way how we can transform data in and out from CDM, and specifically looked at the parts which are interesting or closer to my heart, which is the economic data. So we are slightly orthogonal to most of the other experiments with LLM. And I think when we talk about the emerging standard, the ability to get in and out data data in this or from this format is extremely important for the adoption, for the ease of use, for the ease of migration. So the question of having quality tools available to people to migrate and transform their current trade stores or flows and so forth and so on in and out of CDM is extremely important question. The question of efficiencies is as well quite an important one. And we ventured on a journey to look into two use cases, basically. And I can say upfront, the one was actually quite a good success. The second one was I would say, a mixed bag of experiences. The first one was we took let's say, a mapping between creating a mapping between CDM and FPML or executing and using ChatGPT. It seems to be the tool of choice, using some few-shot learning and a little bit of pre-processing techniques. In this case, we had about 74 publicly available pairs of CDM and FPML. We had to do some flattening of the FPML in order to achieve at all some good results or some acceptable results. And the flattening happened in the sense that if you had an attribute which is trade, swap, product type, enclosed in different tags, we just created one artificial tag which is just trade.swap.product type, and then the value of the thing, which seemed to help ChatGPT to easier understand and translate. However, having said that, in this example, based on the 74 traits or pairs, we've split it roughly 1/3 training, 2/3 training, 1/3 test. We achieved for some of the trait types good results, but for some other trait types, the results were less than encouraging. I would say we had errors from wrong data to wrong structures and so forth and so on. Now, whether this is just based on data quality or some deeper issues, that's a different question. The other example which we did, or the other experiment which we did, was we took a very CDM-like JSON, real trade data with real PDFs containing the terms and conditions. And again, we're looking here at a different angle to CDM, because CDM is quite a rich format, which holds everything about the derivative, including documentation, processing, and so forth and so on, and the economic data. So we looked specifically at the economic data, describing the trade from economic perspective so that we could run risk and whatever, valuation, pricing, these kind of activities on them. That worked astonishingly well with a fairly small subset. So I think we took 40 deals. We split them 30 training, 10 for testing. All test deals passed without a difference. Basically, the generated JSON was perfectly matching what we had as a blueprint. Not necessarily the structure, but the data was the same. The structure was the same. Ordering might have differed, but these are differences which are not changing the semantics of the data. So it was a very successful experience. So in conclusion, I can say the failure of the one experiment might be due to, let's say, our methodology being flawed. Might be we should have looked into splitting or looking into or using multiple agents to look into different aspects of, let's say, FPML, identifying legs or other substructures, so that we can combine it back into one translated unit. However, it appears at this point of time that converting structured data to structured data to be a bit of a challenge and might require some additional or hybrid approaches where we use deterministic non-AI methodologies spliced together with AI technologies. The other way around, translating unstructured data to structured data, surprisingly, worked much better. Well, these are the results. I'm sorry we haven't prepared a demo on this data, but I guess given the other presentations today, people would be aware how this process works and how it looks like. Especially using ChatGPT seems to be very, very popular technique those days. So I assume most of you have seen it, used it, and have a good understanding. Thank you.
So any questions for Plamen? Any? Okay, let's see if we can show something. That is, if I can master my own computer. Yeah, I'll take that any day. Okay, so the architecture we talked about earlier, this is a prototype of it working. We have two different users. Bank one is our bank, and we have a user bank one, and hedge fund one, and hedge fund user one, right? We've got trade information that's been received by the bank and information that's been sent, and similarly, similarly for the hedge fund. So let's look at let's look at from the hedge fund's perspective, a deal that has been received. So 3B whatever. Here are our choices. We can accept the trade, we can reject the trade, we can calculate risk on the trade, we can flatten the trade, or we can reconcile the trade. For the sake of fun, let's just accept the trade. Okay, so that tells us in our very beautiful way that the trade's been accepted, right? And that's 3 whatever. And if we go back to the other one, three weeks later, still 3 weeks later, right? Looking at what we sent has been accepted. So simple demo, using the infrastructure. A trade was we had trades created previously. The mutual parties took action, and both parties were updated. We can show other, fun choices like calculate risk. Here we need to provide a date to use for the market environment. Yeah, it's going to work. Oh, failed to execute. I must have put the date information in incorrectly. Why is it that it only breaks when you do the demo? This one's going to work. It'd be pretty embarrassing if it broke. This one broke too. I think this one's going. Yeah. So for the fun of it, this is CRIF having been calculated on that interest rate swap. And what we don't have, but is because of the infrastructure works the same way, right? We can share the CRIF results, say, oh, here's what I think the risk is of the trade, back to the hedge fund or back to the bank and say, do you accept my calculations? So, any more questions? Go.
The functions that they just executed are CDM functions, right?
Some of them are, right? So, sorry. Let's look for a good one. Well, the simplest one that we have is create. Right, and we'll create by using everybody's favorite standard JSON, right? And so that essentially just created a trade, right?
So you're using native CDM function to...
Well, yeah, at the moment we're using the Python implementation, right? So, but the, loads of detail. The Python library still doesn't support functions fully, but once it does, essentially any that are available in the Python library will be available to CDM. More questions?
So the example that you just showed, right, for the REST model function, whatever that is, the proportion, right? It's kind of normalized across the two entities.
So what I showed, just to clarify, was it's using CloudRisk's infrastructure to calculate risk and present value, and for that matter, CRIF, and CRIF, of course, is a standard, right? So using that infrastructure, it's for either party, but the parties can share it as a mechanism to agree that they both understand the trade in the same way. And in particular, with respect to CRIF, it's sharing present value is a great way to know that you have the same terms and conditions. Sharing risk is an even better way, and CRIF is something that's going to be used to calculate your margin, right? So that full cycle seems quite valuable. Yeah? Any more? No? Hopefully it was helpful. And enjoy the rest of the show.